Hi, good afternoon, beta.
Good afternoon, sir.
Good afternoon. Okay, can you guys see my screen?
Yes, sir.
Okay, let's start. तो कल we were or yesterday we started with kinematics, and within kinematics we started with the variable acceleration, a particle under variable acceleration, and again the scope at this stage for class 11th. Typically we constrained ourselves with one-dimensional motion so that we can understand the dynamics behind the variable acceleration a bit more easily. Okay, so we'll carry on from there. Were you able to look at the anti-abhyas questions from this topic? Okay, so number one. So we started with number one. Let me just in the continuation of what we discussed yesterday. So we will look at the one more question, and just as a quick recap, what do we have in this particular question type? We will be given either the velocity or the position as a function of time, or you might be given even acceleration as a function of time, and you will be asked to determine the other two kinematic variables. So, for example, if velocity is given as a function of time t, then you might be asked for to determine the position as a function of time t or the acceleration as a function of time t. So depending on what you are given, you either would have to differentiate or integrate. And in Chavi, in case we are getting comfortable with differentiation and integration, what do we have in differentiation? Differentiation, we essentially are trying to understand how does one variable, say y, changes when you change other variable on which it is dependent, say x, right? And the rate at which it's changing with x is the slope or dy by dx. So we kind of talked about those things yesterday. There was a question, so we'll do one more question and then we'll move on to the next question type. Let me just kind of read through number C here. What does it say? Given the information on two of the three kinematic variables at 2 points in time, determine the requested information about the third variable in that time duration. Okay, so that would be a further slight variation. Okay, but anyway, let's carry on with one of the anti-abhyas questions. So let's quickly do this question and then we'll move on, unless you guys have any doubts. So what do we have here? Given below are the equations of motion for four particles A, B, C, and D. Position of x is given as a function of time t. Same thing with B, C, and D. The particle moving with constant acceleration is which one? Fairly simple and straightforward. Particle moving with constant acceleration.
Sir, B.
Sure. What about A, by the way? Even though, of course, supposedly it's not given to be the answer in this case. But what will be the acceleration of A?
0.
0. So if I were to check this question, whoever has constructed this question, they had the right intent in mind, but sometimes unknowingly some doubt or some the controversy kind of creeps in, because even zero acceleration is a constant, right? So if you're moving with constant velocity, that zero acceleration is still a constant acceleration, and the particle is moving. So the d1 is not moving, right? So d is stationary.
So, wait, I was going to say that. So, A may it is there's zero acceleration, but D is also technically zero acceleration because the object is not even moving, right?
Right. So if I were to stick with the statement of the question, it says the particle moving with constant acceleration. So d is not really moving at all.
हाँ ठीक है सर.
This is interesting. They have looked at, okay, so they have said the acceleration of A is 6. That's fine. The particle A moves with constant velocity. That's the definition that they're choosing. Okay, let's move on to the next question. So once again, we are dealing with a scenario where the particle is moving under variable acceleration. So acceleration is not constant, right? And here you might be given the v versus time graph, the velocity versus the time graph, and you'll be asked to determine either the displacement or position or acceleration. Displacement, position or acceleration. So let's quickly talk about all three. So let's take any scenario. So let's talk about this one, the one that we have up here. So let's say that the durations are, this one is time t1 and this is, so it remains at constant velocity till from t1 to t2. So let's quickly comment about the acceleration. What is the acceleration is constant between the time period 0 to t1. Then acceleration is 0 between t1 and t2. And then it is decelerating at a constant rate. So again, a constant acceleration scenario, just that the acceleration is negative over that duration. Correct, Namita? Yes?
Yes.
Okay, so let's talk about the distance and displacement. So what will be, will the distance and displacement in this scenario be the same? Will the distance and displacement in this scenario, in the scenario where the particle is moving as per this graph? So this graph represents the velocity versus time. Velocity of the particle as a function of time t. So the question is, will the distance and displacement of the particle over any duration, time duration, be same?
Yes, sir.
Good. Is the particle moving in the same direction or is it changing direction?
So in a 1D graph, this would be in the same direction only, right? Because velocity is not becoming negative.
And what do we mean by 1D graph? What do you mean by 1D graph?
So either the particle is going in the positive direction, which will have like a positive velocity, or it will turn around and go in the other direction, which we will take as a negative side, right?
Okay, so let's
in one axis.
So let's draw that scenario where the particle changes direction. How about this scenario? Okay. So now let's talk about, and once again, this is velocity as a function of time t. Velocity as a function of time t. So the question is the distance and the displacement same for the time duration 0 to t1? 0 to t1 is the distance traveled by the particle and its displacement for any duration between 0 to t1, is it the same? इस ड्यूरेशन के लिए will the distance traveled by the particle be equal to its displacement in the duration 0 to t1?
Yes, sir.
It is the same. Is it the same or different between 0 to t2?
It's a different.
It's different. From the looking at the graph, is the net displacement nearly zero? Looks like the net displacement is nearly zero. Would you guys agree with that?
Yes, sir.
What does the area under the curve represent?
Displacement.
Displacement.
Displacement. And if we give positive sign to all the areas, then that will represent distance.
Yes, sir.
Okay, okay. So if you were to calculate, your displacement for the the segments separately, and just take their mod value, you will get the distance. Okay, now let's ask one more question. Let's talk about this scenario. So what do we have here? So this is V, this is T1, this is T2, this is T3, this is T4. Okay. So before I talk about this scenario, so let me just name these graphs. I'm going to call this as graph 1. I'm going to call this as graph 2. I'm going to call this as my graph 3. Okay. Okay, so the question is this lecture useful for JEE main second attempt? No, beta. This is not useful for JEE main second attempt for 2022. This is meant for students planning to appear for JEE mains or JEE advanced in the year 2024 or the droppers batch. So beta, this may not be useful for you. Okay, hope that and Ruchika, Chavi, this is a question coming from YouTube. So once in a while, I'll address some of the questions that there might be. Okay, but anyway, let's carry on. So between 1 and 2, so let's talk about the average acceleration. Average acceleration. Okay, so in the graph 1, if you look at the duration 0 to t2, is your acceleration 0 or is your average acceleration? By the way, I'm talking about average acceleration. Can someone tell me the definition of average acceleration? What is average acceleration? Can someone tell me what is average acceleration? Final velocity minus initial velocity divided by the time duration. That's simple and straightforward.
Yes, sir.
Yes, sir.
Chavi, Ruchika, you guys, hope you guys are not distracted by what I mentioned, right? Don't worry about the fact that this is a live video. Do not feel distracted, right? So this is our normal regular class, okay? We'll only entertain genuine questions, genuine thoughts. Otherwise, we're not gonna make a magic show out of this lecture, okay? So now let's talk about the time duration 0 to t3. So Chavi, if I may ask you the question, beta, would the average acceleration in the duration 0 to t3, what would that average acceleration be, beta?
So 0.
0. Okay. Now let's look at number 2. Again, for the duration 0 to t1, the average acceleration is 0. Yes, everybody agrees? Yes, beta?
So second, yes, sir.
Okay, okay. So let me just name certain things here. So let me call this as point A, this as point B, this as point C, point D, point E. So the question is, between which durations, between which time durations would the average acceleration be maximum?
Sir, B. If you're not just looking at magnitude, like.
So for what duration? Because you require duration to be able to define. And don't just go by my question. This might be a trick question. Think it from that angle. The question itself may not have, it's not meaningless, but just kind of carefully think about what I just said. I said, between what duration would your average acceleration be maximum? Assume that all the slopes are the same. Assume that the slope of A to B, B to C, C to D, and D to E in magnitude. So let's assume that all magnitude of the slope is 1. That means the angle that these lines are making is plus 45 or minus 45. So what will be the average acceleration? Will there be any maximum for any duration, or is the average acceleration, the maximum average acceleration is the same as the acceleration of A to B?
So it will be same as the acceleration from A to B.
Okay. I'm gonna move on, Chavi, even if the number 2 didn't make sense. I think number 3 is a better scenario to ask that question. So between what duration is the average acceleration 0 for this graph, V versus T graph? So for duration, yeah.
So starting say T2 तक.
Starting say T2. Is there any other duration that you are given the lines that I've drawn? Can you pick any other duration for which for sure the average acceleration is 0?
T1, T3.
T1, T3. I think guys are ready. Let's kick on with the questions from NT Abhyas. Just to get the flavor for the recent JEE mains questions, what kind of trend there has been, let's quickly answer this question.
Sir, could you scroll down a bit?
Sure.
Sir, won't it be A?
Yeah. So एक बार आप CD फिर से दिखा सकते हो options. Yes sir. A.
Sir, but I had a doubt. Sir, why is there a vertical line between? Will there be a vertical line like shown in graph A?
No, beta, there will not be any solid line. There should not be a solid line. There should be a dotted line for its sudden change in velocity at point M. Okay, sudden change. So there is a discontinuity in the slope. So there is no way we can represent acceleration for that duration, right? It should be a dotted line. Okay, let's move on. Let's quickly do it, and then we'll move on to the NT Abhyas and JEE Advanced questions. For the students on the watching lecture on the YouTube, so this question the question is asking us to determine the total distance covered by the body in 6 seconds. In 6 seconds, you have been given the velocity versus the time graph. We talk about the distance.
Sir, A option.
A option.
Yes, sir.
Okay. Even I'm trying to think in my head. Okay, so this is 4 plus 1 by 3, 13 by 3 time between 3 seconds to 4.33. And for the SCD, the time duration is 1 second plus 2 by 3 seconds. Right? So that is 5 by 3 seconds. Y coordinate is visible. Okay. Yes, A is the, sounds like A is the right answer. Um, okay, we'll give another few seconds to the students in the live class to answer, and then we'll move on to the next question. Chavi beta, you are trying to find out the area, correct? No?
Yes, sir.
Okay, okay. So you're just trying to figure out the math of that, right? Or is there any conceptual doubt where I can help?
No, sir, no doubt.
Okay.
Sir, but what I didn't understand is how will I find the area because like the exact points are not given.
Let's see the exact points if they're given or not. A and B, they are 4 meter per second. For point C, the coordinate is -2. For the x-intercept at S, it is given to be 4.333. That means roughly about 1 by 3. And so now you have for A, we can take this as, I see where you are struggling, but take that as A is at x is equal time t equals to 2 seconds.
So A is at 2 seconds.
Ruchika beta, what have you taken? Have you
Yeah, I've taken 2 seconds.
A
And
2
for
seconds,
and B?
B at 3 seconds beta.
Oh, so then it's easy.
Then it's easy, no? Okay.
Yes, sir.
So sorry about it. So we'll move on. Sometimes the diagrams, as they are copied from the one source to the other source, the quality of the diagram takes a hit. Let's take a stab at this question.
Sir, but जब हम actually main से advanced लिखेंगे, then the diagram will be proper.
Absolutely yes. J advanced, absolutely yes. J means yes. What I mean by yes is I have not seen any key mistakes in the J main exam, but once in a while, J advanced tends to be very technical, right? Because the whoever is working those is designing the paper, they have been trained to be very technical, very technical. Not to say that NT examiners are not technical; they're also technical, but it's just the who's the target audience and what kind of level you're trying to set yourself up for, right? So the answer to your question is yes, the graphs would be accurate. You wouldn't have to worry about what is that value, what is that. Yes, beta. करें ये वाला question करें. For folks on the YouTube, take a look at this question. Rocket is fired upwards. Engine explodes fully in 12 seconds. Engine explodes in 12 seconds. The height reached by the rocket as calculated from its velocity time graph. So we are given the velocity time graph. So if we are given the velocity time graph, we can figure out the distance. The distance is, what is the distance? Distance is the area under the curve, right? So go ahead with that. By the way, as per this graph, the rocket is still moving in one direction, no? The velocity for the entire duration of 132 seconds, the rocket is moving in one direction only. So what is the total distance traveled?
So the answer I'm getting is not in the options.
Yeah, sir, same.
What is the answer that you're getting, madam?
Sir, 13200.
Yeah, same. 13200.
One 13,200. Okay, 13,200. So unless there is something wrong with there's an error here. So the velocity is not 200 but rather 1200. So there is an error in the graph there. It should be 1200. That's why it's not in the options. Okay, let's move on. Next question. The following figure gives the movement of an object. Select the correct statements from the given choices. So beta Bhargav, Kashyap, go ahead with this question, beta. Try this question out. So we have been given the movement of an object. So we have been given the speed versus the time graph. We've been asked to select the correct statement from the given choices. So what is the total distance traveled? Okay, but I'll give you some time to work it out. For the folks on YouTube, so the four options, you'll have to figure out the acceleration, the maximum deceleration, and the total distance traveled, and also tell whether the object was at rest between the 10th and the 15th second. 10th and the 15th second. Well, if I were to start from the D, doesn't look like the particle is at rest. Rather, the velocity is between, or it is 15 meters per second. So the particle is, of course, moving between the 10th and the 15th seconds. Okay, Bhargav, I see that you are, Vida, you have to write down your doubt if you have any doubt. I see maybe the chat is not giving me the full information here, but I only see 3 dots. Not sure what that means. Look at the maximum acceleration. Maximum acceleration is either between 0 to 10 seconds or between 15 to 25 seconds. Okay, I see, Bhargav, I see your answer. It says, which option is the right one? 10th constant. Okay, between the 10th and the 15 seconds, it's constant velocity or constant speed. Yes, that is correct. So let's quickly figure out the other 3 options, which ones are right. What is the acceleration, maximum acceleration? Is it 2.5 or is it 2 meters per second square? Another 30 seconds before we move on. But another 30 seconds before we move on. Are we close to the answer?
Sir, A answer.
A is the answer. Okay. Shavi?
Sir, yes, sir. Yes, fine.
Let's go ahead and touch upon I'm going to quickly look at the third question, and then we'll dip into the JEE advanced question, just to see if we have something exciting there. What is this question is asking? It says the figure shows the v-t graph of a particle moving in a straight line, starting from rest, the time after which the particle returns to its starting position. Okay. Okay.
सर
Yeah. Yes, बेटा.
सब प्रीवियस वाले क्वेश्चंस में मैंने शुरू में ही आई रियलाइज कि जो बी सी डी ऑप्शंस तो गलत थे ही सो इंस्टेड ऑफ कैलकुलेटिंग द एरिया वी कुड हैव स्ट्रेट अप सेड इट्स ए राइट बिकॉज़ बी सी डी वर ऑल रॉन्ग
Yes, yes. In the exam scenarios, the process of elimination does work fairly well. If you are convincingly able to rule out 3 of the options, then yes. And you're right. Finding the distance takes longer time. Okay. Here, just assume that the particle is moving at the same negative acceleration or acceleration pointed in the minus s direction from 20 seconds onwards, right? So use that knowledge to find out when will the particle return back to its starting position. So when will the particle return back to its starting position? The net displacement would be 0. Feel free to, so you can approach this question either graphically or you can use your equations of the kinematic equations for constant acceleration for certain segment. Either way. So what is the area of this, or what is the distance traveled toward the positive direction? So the particle travels, starts from, let's say, at t equals to 0, it's here. Then at t equals to 25 seconds, it stops. And then it starts to come back. So how much is this distance? $250. I'm assuming that the velocity is in meters per second here. Now for this part,
Sir, I'm getting A.
you're getting 8.
Yes, sir.
Yes, sir. A is fine.
A is good.
Hmm.
Okay. And how did we determine A beta? What was the acceleration? Deceleration in the other direction?
So minus 4 meters per second.
Yes, sir.
Minus 4 meter per second square. I'm going to drop the minus sign, and I'm going to straight away use that S is equals to ut plus half at square. Now for using this equation, even though we have not learned to use this equation as of now, you can take your starting point for this equation as time t equals to 25 seconds. Because remember, in this equation, what is this t? T is the time duration. So you can choose to start at any point, and you can set your clock as t equals to 0 there, and then from there measure your time duration t. If you measure from there, then your u, the speed at that point is 0, so u, or the velocity is 0. So what is the distance traveled? Distance traveled should be 250 meters. It should be half into 4 into t square. So that is t is equals to square root of 125. What is square root of 125? That is 15.
No, sir. 225 is 15.
Sorry, 225 is 15. 225 is, so what is the, let me just use the quick, this will be around
5 root 5.
5 root 5,
11.22.
11.2, because 11 square is 121, so the closest is 11. So that's where now the total time is 25 seconds plus 11.2, that is 36.2 seconds. Okay, good job. Let's take a look at the JEE Advanced question. Now this is a pretty good question. So you have a choice, beta. Either you can take this question for to attempt at home and then come back and we'll discuss it in the class tomorrow, or if you guys want to take a stab at it right now, you can do so. It will take you 5 to 10 minutes to think through it at this stage. What would you guys like to prefer? Why don't you guys take this as a homework, okay? So take this as a homework. Think fairly good question, okay? Fairly good question. And let's discuss this tomorrow.
Okay, sir.
Okay. By the way, this question has been discussed in the explanation video. So you can refer to that as well if you want. Okay, moving on. Next type of question, or next concept, or next application of the concept. So one thing that I'll keep talking about is the application of the concepts, right? Because concepts are fairly limited if you think from the core concept standpoint, right? The applications are varied, and in other words, so we just need to learn, we just need to develop the skill to apply the concepts in different scenarios accurately. Okay, that's what physics is all about. That's what you will be tested on, especially in JEE Advanced, whether you can apply your understanding to different complex looking scenarios, because in the real world, that's what will count. That's what engineering is all about. Utilizing your knowledge and understanding understanding to new scenarios, right? Okay, so what do we have here? So once again, for a particle under variable acceleration, you might be given acceleration a as a function of time t, right? Acceleration a as a function of time t, and you might be asked to determine the parameter of interest, say for example, maximum speed, right? Maximum speed. It's not that difficult, right? So how would we approach it? If we are given the acceleration as a function of time t, then recall the definition of acceleration. A is rate of change of velocity. Acceleration is rate of change of velocity. A is dv by dt. Okay, so acceleration is dv by dt. So if you are not very comfortable with integration and the differentiation, so these steps may look new, but as you will see them repeatedly, it will start to make logical sense, right? So don't feel discouraged if it feels like, hey, there is a lot of math going on. The level of the math is main what you see today, right? Throughout the physics, the level of the maths is not very high. You just need some basic concepts to deal even with the most complex questions. So I can bring dt. After all, what is dt? dt is a very small time duration, small. And in one of the other classes, we'll talk about what do we mean by in differential when we write dv by dt. When we say d is a differential time, very small time, right? How small? Some the question does come up in mind, right? So how small are we talking about? Second, millisecond, second, minute? Well, it depends on what you're trying to measure, right? You are trying to measure an event that is in hours. For example, let's say you took a flight to Frankfurt, right? That's an 8-hour flight. And you are trying to figure out let's say, some event over this longer duration, right? Some event over this longer duration, then, and let's say that um, the speed of the plane is changing very, very slowly, right? Very, very slowly, pretty much the steady thing. Then you can relax your dt limit, right? But if you are trying to measure something that's changing speed very quickly, I'm just picking speed as an example, then your dt should be very small, okay? Anyway, so it's all relative to what you're trying to measure, that will determine, and how in that event how quickly things are changing will determine what should be your dt. But anyway, let's not worry about that. A is equals to dv by dt, so dv is a dt. Instead of we have taken dt to the left hand side, now we're going to integrate. The right hand side is purely a function of time. The left hand side is a pure function of full differential in v. Okay, so if we integrate, let's say the particle, you're given that the particle starts from rest. The particle starts from rest and it attains some velocity v after time t, and your time is measured from t equals to 0 to some time t. So if you take acceleration as a plus bt plus ct square, then your integral will give you at plus b t square by 2 plus c t cubed by 3, and this will be your velocity as a function of time t. Chavi Beta, you might want to get comfortable with, I think you might already be very comfortable with differentials of polynomials, trigonometric functions, right? Sine, cosine, tan. You are comfortable with those things, Beta?
Yes, sir, relatively comfortable. That's not a problem.
Oh, good, Beta. And Ruchika, I think you are comfortable as well, correct?
Yeah.
Okay. Okay, let's move on. Let's go ahead and attempt this question. JEE Main 2021 question, fairly recent question. Let's take a stab at it. For those joining on the on the channel, on the live, on YouTube, and watching the live broadcast. Um, so if you have any doubts, please do ask the question, and I'll try and respond to the best I can. So this is not purely the YouTube class. We have a live online class, not a very big class, a fairly small class for the JEE advanced students who are targeting um, IIT as their um, as their as their dream goal there. Um, but if you have any doubts, please do feel free to ask them. I'll try and answer them as I can. So we have not spoken about the force and motion part yet. So far in the kinematics, we only talk about the motion of the particle. What's causing the motion will focus in the next chapter, right? The force and motion. But since here they are talking about force, use the Newton's second law, F is equals to ma, to figure out your acceleration, and from there figure out your velocities. So Bhargavita, if you are still there with us, let me know if you have any doubt, but I think the question is fairly straightforward. But if there is any difficulty with the integration part, then I can try and guide you on that. Open this t minus t square, right? And then remember that for any x to the power n, integral of x to the power n dx will simply be x to the power n plus 1 divided by n plus 1. So once again, integration of x to the power n is x to the power n plus 1 divided by n plus 1. Yes, beta ji, are we doing okay?
Sir, is it coming out to be?
Coming out to be
Sir, C option.
C option. Okay, I'll wait for confirmation. Chavi, beta, I'm going to attempt it along with you. So let's see what it comes out to be. Ruchika, beta, have I missed out on a factor of 2 here?
So just checking.
Okay. Let me quickly see the options. By the way, I figured out where my issue is, where I went wrong. The duration is not 0 to t, duration is 0 to 2t beta. Okay, so you are right, Ruchika. So I should be able to replace this capital T with 2t. So the answer will then will come out to be 4 by 3 f0 by m times t. आगे बढ़ जाए बेटा. Shavi?
Yes, sir.
Okay, good. Let's take a look at JEE advanced question. 2004 question, okay? Let's give it a try.
So 55 meter per second.
हाँ sir.
That was quick.
सर ये एडवांस में आया था.
ये advanced का question था 2004 में. 2004. So remember that if you are thorough with your concepts, there would be around 40% of the questions would be some that if you have practiced fair enough, right, all sorts of questions, you should be able to get that many marks. Not every JEE advanced question is going to be mind-boggling, okay? Okay, can you guys tell me how you approached it, Chavi? Can you tell me how you did it?
Sir, since like I just found the area under the graph, right?
So that'll give you, what will that give you?
So technically that gives velocity, but since it's not going negative or anything, you can equate it to speed as well.
Okay, so hold on. Ruchika beta, how would you argue or in favor or against what Chavi just said?
Sir, since the acceleration is not going negative, so the speed will increase and it will be equal to the velocity increase.
So you agree with that, right? So,
Yes.
so the acceleration in the same direction, the velocity will keep increasing. So the maximum speed will happen at time t equals to 11 seconds. Yes?
Yeah.
Good. Let's quickly take a look at the NTF asked question, see if we missed out on something. Looks like an interesting question. The image is a little bit blurry, but don't worry about it. Give it an attempt. Chavi, beta, before we go further deep into the question, can you describe how you understand the situation? Even though we will talk about uh, the uh, the rope and the pulley systems in the next chapter, but since the question showed up here, why not? We'll talk about it a little bit at this point as well. So, can you tell me what's going on in this scenario? So, what's happening at t equals to 0?
So to be honest, I did not understand it fully, but in my what I think I got here was that so one end of the rope is being pulled, and since the entire thing is attached to a three pulley system, the obviously the box B is being pulled as well at a velocity that is given with 12t, and yes, so that's all I got from that.
Okay. Um, okay. So the block B starts from rest and accelerates at this simultaneously. At the same time, the string on the other hand is kind of being pulled at t 0. So I'm going to assume that at time t equals to 0, before t equals to 0, neither the right end was moving, neither the left end was moving, and the block A was stationary. Okay. Now at t equals to 0, what is the acceleration of the block A? Is it moving up, or is it, what is the acceleration of the block A? Is it moving down? Is it moving up? Or is it stationary? Or is the acceleration 0 for block A at time t equals to 0?
So it's moving up.
Is moving up. Can you tell me the acceleration of it, Peter?
Uh,
Now, this is how you figure out, this is how you would link for mass pulley systems. This is how you will work out uh, the relation between the acceleration of different masses. Okay. So in this scenario, let me ask you this. If the block A moves by a distance y, by how much distance will this end move towards the right?
2y.
2y. Excellent. And then at any point in time, if you assume that B is stationary, then that would be valid if only the right end was moving. Correct? No?
Yes, sir.
Okay. So if you were to double differentiate that relationship, will you get the relation that so if I were to write the acceleration of A is equals to d2y by dt, so acceleration of B will be d2 by dt2 of 2, so that means 2 times the acceleration of, right? I'm only going to do it this once. Going forward, I think if you can figure out the relation between their just moved, you can straight away tell the relationship between their accelerations, right? So what does it tell me? That the acceleration of a at t equals to 0 is half of a0, right?
So I didn't understand this.
See, so you just said if a were to move from here to here, will actually move to y, right? This rope will be here, this end of the rope. So what will be the relationship? So the relationship, same relationship will hold true, even though I'm making a statement here, and we'll take a look at it as well, right, Peter? I'm saying y is the coordinate measured. Let's say this is the initial position, and this is how you measure y. And let's say this is the original position, and this is how you measure its distance, right? This distance is to y, or let's call it x. So what is the acceleration of this? d2y by dt2. What is the acceleration of this? Well, acceleration तो यही होता है ना बेटा. What is the acceleration? Acceleration is dv by dt, and v is equals to dx by dt. So this might be new a little bit. What does this double derivative means? Well, that's what it means actually, right? Double derivative means d by dt, rate at which the velocity is changing, d2x by dt2. Yes, beta?
हाँ sir, yeah.
Okay. So this is the acceleration of, I'm going to call it, this is A, this is B, I'm going to call this as C, not B. Not, sorry, I used the alphabet B. B actually refers to this one. I'm talking about this end of the row. So what is the acceleration of C then? Agar x, if you were to replace x by 2y, you will get 2 times d2y by dt2, which means the acceleration is 2 times the acceleration of mass A at time t equals to 0. Yes, beta?
Okay, हाँ sir. ठीक है.
Okay. Now, at any time t, this is just to get ourselves warmed up, right? Just to get ourselves going. But now, if you are given that the acceleration of B is 12t, acceleration of the right end of the rope is a0, can you guys now tell me what will be the acceleration of A as the function of time t? What will be the acceleration of A as a function of time t? B is moving towards the right, the right end of the rope is moving towards the right with acceleration a0, and once again B is moving with acceleration 12t. It's a function of time. So what will be the acceleration of block A? What will be the acceleration of the block A as a function of time t? Think about it this way.
Would it be 60 minus a naught by 2?
60 minus a naught by 2.
Sir, 60.
60.
Yes.
60 minus a naught by 2. And is that acceleration upwards or downwards?
Sir, this is downwards.
Okay. We know at time t equals to 0, actually it's moving upwards. So just for the convenience, you might want to take it a0 by 2 minus 60.
Yes, sir.
Good. Shavi beta, shall I give a small hint? So you might want to think, you might want to break it up in your head, right? Just initially, just look at, let's say, B. If only B is moving towards the right, if B moves by a distance Z, right? I'm just picking up another variable here. So if B moves by Z, by how much will A descend? A will descend by Z by 2, right? Now, if you were to superimpose on that movement, the movement of the end C, that what I've written here, right? If C moves by X, then this one will move up by X by 2, right? So by how much does it move upwards? X by 2 minus Z by 2. Differentiate that. So what do you get? The acceleration is A0 by 2 minus acceleration of B by 2. So that is 60. Yes, beta? Chavi beta, is that clear?
Sir, kind of.
Kind of, okay. So once again, if B were to move by distance Z, then by how much will the pulley move down? Assuming that the right end is not moving, right? So the amount of rope, the Z amount of rope that has become free now, it will get wrapped up on the both ends. It will get wrapped up on the both ends, right? So it will distribute itself on the left side of the pulley to which A is attached and to the right side, right? So the downward movement of A in that case would be Z by 2. Okay?
Yeah.
Now move the other end of the rope by distance y, by distance x. तो कितने से ऊपर आ जाएगा? By how much will it rise up?
X by 2.
X by 2. So minus z by 2. So it has come down by minus z by 2, then goes up by x by 2. Right? So what is the net displacement it has in the upward direction? X by 2 minus z by 2. This is y. So then that means that the acceleration of block A is equals to the A0 by 2 minus acceleration of B by 2. Just taking a simple double derivative there with respect to time t. Yes?
Yes, sir.
Okay. Now that we have the expression A naught by 2 minus 60, the question says when does it come to rest? Right? Now we know how to proceed with that. Correct? How would we proceed with that, beta? Ruchika, how would we proceed, beta? You will first find out the expression for the velocity as a function.
Yes, sir.
Then integrate that to find the displacement.
Yes, sir.
Okay. And then the net displacement should be 0.
Yes, sir.
Okay, that will give you the time. Yes? Or it's asking for something else. Sorry, it has already given you the time. T equals to be 3 seconds. It's saying what is the value of A0. So do completely finish this question, Chavi, okay? Ruchika, if you have not done this earlier, you might want to solve this in the entirety as well, beta. Okay, and do that question, JEE Advanced ka, previous question type.
Yes, sir.
Okay,
Yes.
good. So how was the class, Shavi? Did it make sense?
हाँ sir.
Okay. ठीक है बेटा. I'll see you guys tomorrow. On Thursday we will not have a class, beta. So we'll have to reschedule it for either Friday or we try and absorb it next week. So we'll have to do one of the two. Thursday I will not be taking any classes.
Okay sir.
Alrighty, you guys have a wonderful evening, and I'll see you guys tomorrow, same time, 5 p.m.
Thank you, sir.
Alright,
Thanks,
take
sir.
care. Bye bye.